Okay, so interpreting p-values in two-sided tests. Let's just look at that again. Again, let's say we have this body satisfaction measure that we're doing on Instagram. So checking how satisfied with their bodies people are. If you don't use Instagram, you have 4. If you use Instagram, it's 3.4. 3.4. You're less satisfied with your body. Cool. The difference in satisfaction is minus 0.6 because it decreases when you use Instagram. Right. Okay. So in this case, minus 0.6. And again, you might be confused because before we're using depression, the higher your number, the more depressed you are. Here, the higher number, the more satisfied with your body. Okay, so here we're flipping. The less satisfied with your body, the lower your number, right? So that's why it's negative. So negative 0.6 is the main number that we found with a p-value of 240. Well, if you look at a p-value of 240 in a two-sided test, that's what? 25% total, split into two sides, 12 and 12%. That's all I'm showing you. Okay, so 12%. And then we can make all the statements, like 12% of the values in this H0 are negative 0.6 or less. You can say all those things. Now let's interpret the p-value in a one-sided test. You have a one-tailed. Let's use the example of sunscreen. Okay, so sunscreen is a perfect example for a one-sided test. Why? You're going to put on sunscreen. It's not like you're going to burn more. You understand? Like, we know sunscreen enough that it's not going to burn your skin. It's only going to protect your skin. Now we want to know if the protection is 0 or not. So what are we doing? We're testing sunscreen and we're measuring how burned people are. Okay. So if you wear sunscreen, which is this first thing, you're going to have burnt 2 out of 7. And if you don't wear sunscreen, you're getting burnt 7 out of 7. So how burned are people after using sunscreen compared to people who didn't use sunscreen? So the difference in burnt and the satisfaction with the sunscreen is minus 5 with a p-value of 0.04. You can see here, if you plug in minus 5, the p-value of 0.04 allows us to know that this is significant. Why? Because 0.04 is smaller than 0.05, and this one-sided no hypothesis now is 0.05 on this side, right? So that's good enough. So this is how you draw it. Okay, this is how you'd see it. Attention. So pay attention that the p-values are different than the alphas. The alphas change. The alphas shift, and the p-values do not shift. Okay? The alpha, the chance of type 1 error, number and area stay the same, but the cut point shifts. Okay? So the area here is 5%, but it's just sucked up to the other side here on a one-tailed hypothesis. And the cut point, which used to be 1, shifts to 0.82. P is the chance of this number that we found be coming from world 0. The number and area changed because before we had 3%, now this other half disappeared. We only have 1.5% represented by this, but the cut point stays the same. So they're kind of like opposites. Okay, so this is it. I'll see you next time.